So here we are in part 2, talking about the properties of exponents and order of operations. So here are our 6 rules for exponents. You have your product. So for the 6 rules, and the first 2 in particular, it mainly hinges upon having same bases. So they're both x's. So if you were to have x to the 7th times x to the 5th, this would be x to the 12th. What you want to do is just add your exponents together. For your quotient rule, if you had x to the 7th over x to the 5th, this would become x squared, because 7 minus 5 is 2. Up here, 7 plus 5 is 12. If you have bases that are different, x to the 4th, a to the 3rd, you can't do anything with that, because since the bases are different, they can't be combined. Really what's happening is that whether you're doing the product rule or the quotient rule, if you have x squared and x cubed, x squared is 2 x's, x cubed is 3 x's, so in all, you're multiplying 5 x's, and that's how you end up with x to the 5th. The power rule is an extension of the product rule, in that you're basically saying if you have x squared to the 3rd, well, you have x squared times x squared times x squared. So it's just 2 plus 2 plus 2. It's this rule again. Negative exponent rule says reciprocal. So whenever you have a negative exponent, it basically flips. X to the negative 3rd is 1 over x to the 3rd. Or, for another example, if you have x to the 8th, that's 1 over x to the negative 8th. So since this is over 1, take the reciprocal, you get your exponent. The rational exponent rule basically says if you're doing the a-th root of b, that becomes x to the b over a. So if you had the square root of x cubed, this would become x to the 3 over 2. A square root is the denominator of 2, and since that's a cube. And then lastly, for your 0 exponent rule, anything to the 0 power is 1. However, x cannot equal 0 because 0 to the 0 power is undefined. And if you're looking for something fun to do, this is actually easy to prove that it's undefined if you use your quotient rule. So continuing on, I've got a couple examples here that will hopefully show you how all these rules can play together and work with each other. So the first example I have is if we have a to the 3rd a squared over a. Well, I know I'm going to talk about order of operations next, but you would do the numerator first, a to the 5th over a, because 2 plus 3 is 5, and then this is a 1 down here. It gives us a to the 4th. For the second one, m squared over m to the negative 2nd. There's a couple of different ways to look at this. There's a 1 here, right, for that exponent. And so since this is an m, this is an m, we can combine the exponents here. So you have 1, according to the quotient rule, we're going to subtract the exponents. So if we have 1 minus a negative 2, that's a positive 3. N has nobody to play with, so just kind of hanging out there. Third one I've got here is x to the negative 3rd y squared all to the negative 5th power. So since we're dealing with the fraction, all right, in parentheses, this 5 applies to both. Now if I could simplify what was in the parentheses, I would, but since this is an x and this is a y, they can't be simplified. So this negative 5, according to the power to a power rule, we're going to multiply. So I'm going to multiply that to both the numerator and the denominator. So we're going to have x to the positive 15th, y to the negative 10th. Negative 5 times negative 3 is a positive 15. Negative 5 times a positive 2 is a negative 10. And now to make this look pretty, x to the 5th, y to the 10th, because I'm going to move that negative exponent into the numerator. It's not a hard, fast rule that you always have to have positive exponents, but in your homework and in other courses, it is more convenient to have a positive exponent. I'll put number 4 over here. X to the 0, y to the 5th, all raised to the negative 1. Well, x to the 0 is 1, so we don't really need to worry about that anymore, so this would just become y to the negative 5th. 1 over y to the positive 5th would be the answer there. Z square root of x over y to the negative 1st, and we're going to take this whole thing and we're going to square it. So as we did in 3 and 4, there's nothing inside those parentheses that can be simplified. So we're just going to take this 2 and distribute it to everybody. Z squared y to the negative 2nd. It's this guy here I want us to pay particular attention to. All right, so we have the square root of x squared. Well, the square root of x squared, right, if we go with our rational exponent rule from up here, the square root of x squared is x to the 2 over 2, which is x to the 1st. So this will simplify to z squared y to the negative 2nd, and we're left with just an x. And then, to make it pretty, it's x, y squared, z squared. I put them in alphabetical order, mainly because I like to. It doesn't have to be written this way, although it should be written with positive exponents, but the ordering of them really isn't that important because of the commutative property. Number 6 I have is 2 to the 3rd over 3a to the negative 2nd. So 2 to the negative 3rd, there's a couple ways to do this. Let's fix the denominator first. I'm going to leave it 2 to the 3rd. 3a to the negative 2nd is going to become 3a to the positive 2nd when we fix that negative exponent. 8 times 9a squared. 72a squared would be our answer because we multiply the 9 and the 8. So the last one I'm going to do is a big one. X to the 6th, y to the 3rd over x to the 3rd, y to the negative 3rd, times y to the negative 7th, x to the negative 3rd, and then we're going to do all of this to the 10th power. So my advice to you is, rather than looking at this and going into complete panic mode, break it down, all right? Do smaller chunks first, okay? And that's just something that's a good life lesson overall. I'm going to tackle just what's in here first. All right, so we have x to the 6th over x to the 3rd. That's going to simplify to x to the 3rd. And now we have our y's. Y to the 3rd over y to the negative 3rd. We're going to subtract these. 3 minus negative 3 is a positive 6. And now we have y to the negative 7, x to the negative third, like that. This is over 1, and all of that is to the 10th power. And continue it up here. So we have an x and a y. All right. So we have x to the third divided by x to the negative third. So we're going to subtract. 3 minus the negative 3 is going to give us x to the 6th. Then we have y to the 6th, y to the negative 7th. When we add these, we're going to get y to the negative 1st. All of this will be to the 10th power. So now we're at this part over here, and we have x to the 6th, y to the negative 1, all still to the 10th power. Distribute x to the 60th, y to the negative 10th, which would then become x to the 60th over y to the positive 10th. And there's our answer. So there's a lot of little steps in there. Next up, we have good old PEMDAS, order of operations. So to evaluate mathematical expressions, we perform a multitude of operations. There's actually kind of a funny story here. Really, all this is addition. It's just, excuse me, putting addition into order. Because if you think about it, adding is adding. Subtracting is adding a negative number. Multiplication is repetitive addition. So if you think of multiplication as repetitive addition, like if you have 5 times 4, that's 5 plus 5 plus 5 plus 5. Or it's 4 plus 4 plus 4 plus 4 plus 4, depending upon which way you look at it. Either way, both of those equal 20. So multiplication is repetitive addition. To go about subtraction, if you're doing 3 minus 7, well, that's the same thing as 3 plus a negative 7. Whether you're working with this one or this one, negative 4 is your answer no matter how you do it. So addition is subtraction is adding a negative number. Multiplication is repetitive addition. Now you're probably wondering how division is repetitive multiplication, or is repetitive addition. So if you do 5 divided by 4, 5 divided by 4 is really 5 times 1/4. 5 times 1/4 is 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. That's how you get 5/4. And that works no matter what type of division you're doing. Trying to think of what else there is. Oh, and then when it comes time for exponents, 2 to the third, well, that's 2 times 2 times 2, right? And then you can break this apart into more addition when you really put your mind to it. So really the only thing that, when it comes to order of operations, is that you've got addition, addition, and addition. But your parentheses tell you which addition takes priority over all the other ones. Regardless, though, we're still going to use PEMDAS. I lumped M&D and A&S together because it's multiplication and division from left to right, addition, subtraction from left to right. Really, it could just be PEMA, parentheses, exponents, multiplication, addition, because you can change division to multiplication, you can change subtraction to addition. I don't know why textbooks haven't updated this. I don't. It's just I don't know. I don't know. So the first example I have here is 9 minus 18 divided by 3 squared. So we're going to do our exponent first. 9 minus 18 divided by, well, 3 squared is 9. After we've done our exponents, we're going to do our multiplication and division from left to right. All we have is this guy here. So it's going to be 9 minus 2, because negative 18 divided by 9 is a negative 2. 9 minus 2 gives us 7. Example 2. 14 times 3 divided by 7 minus 6. So 14 times 3. We'll do that first because it's multiplication division from left to right. So we'll do these two first. So 14 times 3 gives us 42 divided by 7 minus 6. Well, 42 divided by 7 is 6. Minus 6. This gives us a happy little answer of 0. Four squared minus 25 times 1/5. Now, I know the rule says parentheses first. All right, but that's when you have an operation inside the parentheses. These parentheses here mean multiplication. So to stick hard and fast to our rules, we're going to do the exponent first. 16 minus 25 times 1/5. Then we'll do our multiplication. 16 minus 5, and we get an answer of 11. Then our fourth one that I have here is 12 times 3 minus 1 divided by 6. So we'll do the parentheses first. 12 times 2 divided by 6. 12 times 2 is 24 divided by 6 gives us 4 for an answer. So those are your exponent rules and the orders of operation. Our next video will deal with radicals.